Hello everyone. In this session we are going to see about evaluation of strains in thin cylinder, thick cylinder and spheres, unit 5, from the paper Strength of Materials for mechanical engineers. So as we know that wherever there is a stress there will be definitely a strain. So in the previous video we had seen the evaluation of circumferential stress and longitudinal stress, and in this video we will see about the evaluation of circumferential strain and longitudinal strain. So consider this is a rectangular hollow block, and in the x-axis there will be circumferential stress or hoop stress will be acting, and in the y-axis longitudinal stress will be acting. And circumference is as we know that circumference is nothing but the diametral part. So this will be the front view of the hollow block. So this termed as diametral portion, and hence the circumferential stress will be acting along in the x-axis, and in the y-axis it will be uh, like length part or longitudinal part, and hence longitudinal stress will be acting along in the y-axis. So sigma c circumferential stress, and PD by 2T is the formula to find the circumferential stress, which was derived in the previous video. Similar that longitudinal stress. So a point on the surface of thin cylinder is subjected to biaxial stress system, that is hoop stress and longitudinal stress, since discussed now. So mutually perpendicular to each other. So everything is perpendicular to each other, that is 90 degree. So the strains due to these stresses, so circumferential stress and longitudinal stress, wherever applicable there will be circumferential strain and longitudinal strain respectively, and that can be obtained by the Hooke's law and Poisson's theory of elastic material. As we know that within the elastic limit the stress will be directly proportional to the strain, that is the Hooke's law, right? So with these two theories, Hooke's law and Poisson theory, the evaluation of strains is going to be made. So the first thing is circumferential strain caused due to circumferential stress. So circumference is the diametral part as we discussed, and hence circumferential strain is a change in diameter by original diameter. So depends on the Hooke's law and Poisson's theory, sigma c by E minus mu into sigma L by E, that is circumferential stress, and this is the Young's modulus of the given material. Mu is the Poisson ratio. So by using Hooke's law and Poisson theory, this relation has been made. Sigma L is the longitudinal stress, and as we know that sigma c is equal to 2 into sigma L, that is circumferential stress will be twice the longitudinal stress, and hence substitute sigma c is equal to 2 into L, and hence this relation will become 2 into sigma L by E minus mu into sigma L by E. So in this relation sigma L by E is the common factor, hence it can be taken out from the bracket. So sigma L by E into 2 minus mu, right? So sigma L is nothing but PD by 4T, right? Sigma L is equal to PD by 4T. Hence substitute this relation, that is sigma L. Hence circumferential strain is that del D by D, that is ratio between change in diameter by original diameter, will become PD by 4T, and this denominator E is same, E into 2 minus mu. Hence this will be the circumferential strain for the given hollow block. So here del D will be the change in diameter, right? And hence it can be stated as circumferential strain is equal to final circumference minus original circumference by original circumference. And in denotation, final circumference is pi into D plus del D. Since circumference can be calculated from circumference of the circle, that is pi D, right? So final circumference will be the strained one, so that is D plus del D. So pi into D plus del D minus original circumference pi D divided by original circumference pi D. So this is nothing but change in diameter by original diameter, that is circumferential strain. And now we are going to see about longitudinal strain, right? Sigma suffix L. So by using Hooke's law and Poisson theory, this relation came sigma L by E minus mu into sigma C by E. Since longitudinal strain, hence sigma L becomes the first one. So sigma L by E minus mu into, replace sigma c is twice the sigma L, and also in this relation substitute sigma L is equal to PD by 4T, and hence this relation will become sigma L by E into 1 minus 2 mu. So longitudinal strain will occurs along the length of the cylinder, and hence change in length by original length, as we know that, will become this PD by 4TE into 1 minus 2 mu, since the sigma L is substituted by PD by 4T, right? So this will be the longitudinal strain of the given hollow block. And the next one is volumetric strain. So volumetric strain is nothing but change in volume by original volume, right? So change in volume is nothing but final volume minus original volume, right? So original volume is nothing but volume of the cylinder, right? So area of the cylinder will be pi by 4 d square, and when multiplying with the length of the cylinder, we will get volume of the cylindrical shell. So volume of the cylindrical shell is equal to area of the cylindrical shell into length of the cylindrical shell. So pi by 4 d square L will become the volume of the cylinder, that is original volume, and final volume is nothing but the extended length due to the stress induced in the cylinder and then strain. So the final volume will become final area of cross section into final length, that is pi by 4. So whenever there is a stress and strain, there will be change in diameter and change in length, and hence pi by 4 d square L is the original volume, and the final volume will become pi by 4 d plus del d square into L plus del L. Here del d is change in diameter and L is change in length, right? So here this looks like a plus b whole square, right? So I'm expanding the equation. A plus b whole square is equal to a square plus b square plus 2ab, and hence that happens d square plus del d square plus 2d del d into L plus del L. So these two brackets getting multiplied, and hence this relation will become pi by 4 d square L plus del d square L plus 2L d del d plus d square del L plus del d square del L plus 2d del d del L. So neglecting the smaller quantities, that is del d whole square, del L, so like that. So these are all very small quantities when comparing to other parameters, and hence final value will become pi by 4 d square L plus 2L d del d plus d square del L. So change in volume, that is del V is equal to pi by 4 d square L plus 2L d del d plus d square del L minus the original volume is pi by 4 d square L, and hence the change in volume will become pi by 4 2L d del d plus d square del L. So the change in volume dV by V. In the previous slide we had calculated volume of the cylindrical shell, that is original volume separately and change in volume separately. Now we are substituting that values in this relation. We will get dV by V is equal to del L by L plus 2 into del D by D. That is the change in diameter by original diameter is circumferential strain. Change in length by original length will be longitudinal strain. So the relation will become dV by V is equal to sigma L plus 2 into sigma C, right? So on substituting the longitudinal strain and circumferential strain values, that is formulas, PD by 4TE into 1 minus 2 mu plus 2 into circumferential strain value PD by 4TE into 2 minus mu, and hence the dV by V will become PD by 4TE into 5 minus 4 mu from this relation. So this will be the volumetric strain of the given hollow cylindrical block. And the next parameter, important parameters, maximum shear stress. So there are two principal stresses at any point. So in this block at any point there will be two principal stresses, that is circumferential and longitudinal. So both these stresses are normal and perpendicular, that is 90 degree to each other. So maximum shear stress tau max will become sigma c minus sigma L by 2. So we know that sigma c is PD by 2T and sigma L is PD by 4T, and substituting this, the tau max will become PD by 80. So this is the relation to find the maximum shear stress of the given cylindrical hollow block. So with this I conclude this session. In the next session you will see a problem. Thank you.